Hi, my name is Daniel. Today I'm going to present about concrete and types of concrete. So, description for concrete. Concrete is a strong and durable building materials made from cement, water, sand and aggregates. When mixed it hardens through a chemical process called hydration. Concrete can be shaped before it sets and is commonly used for foundation, walls, floors, roads and bridges because of its high compression strength. There are many types of concrete, but now I'm going to list 3 only. The first one is normal concrete. It is made from cement, water, sand, aggregate. What is used for? It is used for general construction, such as highways and others. So the second one is reinforced concrete, or in short form we call it RC. It contains steel bar to improve tensile strength, and basically it is a combination of a concrete and a tensile and a steel bar. So the third one is high performance concrete, HPC. What does it do? It is being improved durability, workability or strength using special admixtures. Engineering properties and characteristics. The first one of engineering properties and concrete are compressive strength. Concrete is strong under compression and can take heavy loads. Second, tensile strength on load. Why? Because it is weak in tension, needs steel reinforcement to make it even better in tensile. So the workability, it is ease of mixing, transporting and placing. How do we check? Basically we check using slump test. So the characteristic of concrete are 4. The first one is durability. It is long lasting and resistant to weather, chemical and wear. The second one, thermal expansion. Concrete expands and contracts with temperature changes. The third is fire resistant. Concrete has a good resistance to high temperature changes. The fourth, versatility. Can be cast into any shape before it's hardened.
Here I want to talk about advantage and disadvantage of concrete in construction. The advantage is strong in compression, suitable for heavy structure. Durable and long-lasting, resistant to weathering and fire. It also can be molded into any shape before it hardens. Lastly, materials are easy to obtain and relatively inexpensive. For this advantage, concrete weak in tension unless reinforced with steel. Secondly, take time to cure and gain strength. It also heavy, making transportation and handling harder. Lastly, crack can occur if the mix or curing is not done properly. Application in Malaysian civil engineering project. First one, we got highway and road, such as concrete pavement, bridge, deck and barrier. Second, building, such as foundation, column, beam, slab and wall. Thirdly, dam and water structure, such as spillway, retaining wall and drainage structure. Fourthly, infrastructure project, such as MRT station, LRT tunnel and airport. Fifthly, coastal and marine work, such as jetties, breakwater, and seawall due to durability. Sustainable practice or innovation. Firstly, using recycled aggregate from demolished concrete to reduce waste. Second, we use low carbon cement like slag cement or fly ash to reduce CO2 emission. Thirdly, green concrete using industrial byproduct such as fly ash, silica fume, and GGBS. Fourthly, self-healing concrete with bacteria or capsule to repair crack automatically. Fifthly, the permeable concrete to reduce flooding and improve stormwater management. Lastly, optimize mix design to use less cement while still achieve required strength. Steel is a strong, ductile, and versatile alloy mainly made from iron and carbon. It has high tensile strength, making it ideal for reinforcement and load-bearing structure. Steel also offers excellent durability, flexibility, and the ability to resist deformation under heavy load. Type of steel used in construction. Firstly, mild steel. Mild steel is low carbon, easy to bend, used for reinforcement bar. We call it rebar. Secondly, high strength steel. The highest carbon or alloying element used for high load structure. Thirdly, stainless steel, which is corrosion resistant, used in coastal or chemical environment. Okay. Fourthly, structure steel, I-beam, H-beam, channel for building frame and bridge. And lastly, pre-stressed pre-stressing steel, which is high tensile wire and strength used in pre-stressed concrete.
Hi, my name is Hazim. Today I want to explain about engineering properties and characteristics steel. For properties, we have mechanical properties and physical and chemical properties. And we have characteristics. For mechanical properties, first we have tensile strength. So the maximum stress of material can be withstand while being stretched or pulled before necking or fracturing. For second, yield strength, stress level where it starts permanent deformation. Third is ductility, that can be stretched into wires or hammered without breaking. Fourth, toughness, ability to absorb energy and deform plasticity before fracturing. 5. Hardness, resistant to localized plastic deformation such as indentation or abrasion. Physical and chemical properties, we have density. The density of steel is around 7,850 kg per m squared. And second is melting point. The melting point is varies by alloy, generally about 1,400 Celsius. That is thermal and electricity conductivity. Steel is a good conductor of heat and electricity. Its conductivity varies with the alloy. 4. Corrosion resistant. Corrosion resistant steel, primarily stainless steel, resists rust and chemical attack. 5. Magnetic properties. Most steel performance magnetic property utilized in motors and transformers. For characteristic of steel, we have weldability, generally easy to join, tough carbon content effective. Second is formability, can be shaped into complex form. And third is hardenability, that is with each the material can be hardened by thermal treatment. Advantages of steel in construction. First is high strength and lightweight. Excellent strength to weight ratio allows for long spans and lighter foundation. Second is speed and efficiency. Prefabricated components allow for rapid assembly and reduce construction time. Third is ductility, can deform significantly before failure, providing warning on better seismic performance. And 4 is sustainability, highly recycled with high scrap value at the end of its life. Is disadvantage of steel in construction. First is corrosion, rust in steel areas requiring protective paints or coatings and ongoing maintenance. Second is high initial cost, more expensive than some materials like wood, block at the cost for fireproofing and maintenance. Third is thermal conductivity, transfer heat easily, requiring good insulation for energy efficiency. Fourth is fire vulnerability, loses strength rapidly at high temperature, necessitating costly fireproofing. Application: steel in mission civil engineering project. First, big buildings. Form the skeleton or framework of high-rise to support the weight. Example: Petronas Twin Towers and Hastings 108. Second is bridge and roads, used for the main support beams and long spans to cross river or roads. Example: elevated highway, MRT and LRT. Sustainable practice for innovation steel. First is decarbonization, green steel, switching the main fuel source from coal, which release carbon dioxide, to hydrogen, which only release water vapor. This is the biggest change. Second is recycling and circularity. Steel can be recycled infinitely using a lot more recycled scrap method in electric furnace instead of digging a new iron core.
Now, I'm going to tell you about slump test. So what is slump test and what are the purpose? So slump test is a simple test used to measure workability, consistency and fluidity of a fresh concrete. It shows how easily the concrete can be mixed, handled, transported and be placed on a site. The purpose of slump test to check consistency of concrete from batch to batch to ensure the concrete is not too wet or too dry, to confirm the mix is suitable for placement, compaction and finishing. So what are the tools for slump test? There are 5 tools. The first one is slump cone. The second one, base plate. The third one is tamping rod. The fourth one is scoop and funnel. The fifth is cleaning brush. First of all, it's going to place the base plate on flat and level surfaces. As you can see, he's dampened the slump cone and base plate so the concrete doesn't stick. Next is filling the cone with concrete and tap it 25 times. After 25 times, it's going to put the second round of concrete. After he puts second round of concrete, it's going to tamp it again 25 times. So the last one is going to put the third layer of concrete in the slump cone. After doing that, it's going to tamp 25 times. After it done, it's going to lift the cone slowly by holding both handle firmly, then lift it straight up slowly in about 5 plus minus 2 seconds. Do not twist it or tilt it. After that, you need to measure the slump. Place the rod across the top of the empty cone. Measure the distance from the rod down to the highest point of the slump concrete. This number is your slump value.
Here, I want to talk about compression test. The purpose of compression test is to determine the compressive strength of hardened concrete, the most important property for structure performance. For the equipment, we use compression testing machine. Secondly, we use concrete cube or cylinder sample. From video, firstly, the cured concrete specimen is placed in the compression machine. Secondly, load is applied gradually at a constant rate. Thirdly, the machine records the maximum load before failure. Fourthly, compressive strength equal maximum load over area of specimen. The observation, the concrete sample crack and eventually crush on the increasing load. For the interpretation, higher compressive strength indicate a better quality concrete. Secondly, higher durability. Thirdly, greater load carrying capacity.